Hello again. This is going to be our last video on using the technology to do exponentials, okay? In this case, we're going to do an application problem. So this is the graphing calculator doing applications for exponentials. And we're also going to go through Desmos. So this might look very familiar. I wrote it's the same as a previous video. The function p of t equals 300 times 1.025 to the t gives the population of a town, P, in thousands of people, t years after 1980. As always, I'm asking you to decide what your input and output are and write them somewhere, okay? This is for yourself. The input here, what's inside the function, is t, which is years since 1980. And the output here is p, which is population in thousands. Make sure you're putting the units so that you know how to write your sentences later on, okay? Now, we did this problem in a previous video, but now we're going to do it using technology. So what I'm going to do is I'm going to graph this function. So first I'll use the graphing calculator. I'm going to go back into y equals, and I'm going to put this function. Now I can't type p of t. I'm going to have to realize that my input is going to have to be x's, okay? And my output is going to have to stay y's because my calculator only understands y equals, okay? So it's going to be y equals 300 parentheses 1.025 raised to the x, okay? You're going to have to translate back and forth for yourself that we're really working with t and p, okay? So I'm going to go in and think about my window next, because a standard window is not going to cut it here. How do I know it's not going to cut it? My y-intercept is 0, 300, okay? That's what the point here means. Remember, that's what the a value is. So that's the y value of the y-intercept. So 0, 300. I need to make sure I see 300. Not only that, but we know this is increasing. So I want to even see more than 300, okay? So we need to think about these things before we type anything into our calculator. So I'm going to go to Window, and I'm going to think about the inputs and the outputs and what they mean. The input is supposed to represent years since 1980. Do I care about what happened before 1980? No, I don't. So I'm going to put x min at 0, okay? Because I'm starting this at 1980. So 0 years from 1980. How many years do you think we care about, okay? I think in the previous video, we talked about 25 years. So let's go out to 25 years. I might not want to count by ones because that's a pretty big spacing. So maybe I'll count by fives. That's what my scale would mean. Now, think about your y settings. What's the lowest y value that you might want to see? I like to leave 0 in as a reference, okay? Just so we can see in proportion, okay, what this population is going to look like. So I like to leave my y min at 0. Now, if you're following this along, you're going to go, well, wait a minute. The population is not going to go below 300 because it's increasing. And I am with you. But I like being able to know that I'm always referencing from the origin. So I want to keep that y min at 0, okay? My y max, I know I have to go larger than 300. How much larger? Well, I might have to play around a little bit, but let's see what happens if I go out to 500. My x or my y scale, I'm going to want to skip count kind of large numbers here. So maybe I'll skip by hundreds, okay? And now when I'm pretty comfortable with my settings, I'm going to go to graph and see what that does for me. I knew my y-intercept was going to be 300, so that's not a surprise that it's up here. and I can see the gentle bend of the curve, okay, going off the screen. Now, this doesn't look like much of a bend. If I wanted to really see more of this and exaggerate this, I could go back into my window and then increase this a little bit more. Okay, so maybe if I want to see a little bit more of a bend, maybe instead of 500 as a max, I'll go to 800, and then maybe I'll go out to 30, okay, 30 years, and then go back to the graph. I can see, again, it's starting out from 300. I can see the bend, okay, and it starts to come up. And you can expand this if you want to see more of the sharp curve, okay, but I can see the bend here, okay? So now we can actually use this picture to answer some of the questions that we were asked in that previous video. One of the questions was, find the population in 2005. 2005 is 25 years from 1980. So I want to know what happens when the input, T, is 25. I can just press trace, and I can type in 25, and it will tell me what the output is. And if you remember from the previous video, we got the same exact thing, 556,183 approximately people, okay? But now let's say you were looking for a particular population. I want to know when the population reaches 500,000 people. So I'm going to go to y equals, and I'm going to set y2 to be 500. I want to know, it's just like having a height. I want to know when it hits 500. And then I'm going to go back to the graph. It's drawing a line right at 500, okay, to mark off that output. I'm interested in this point. So I'm going to go to second, trace, it's my calculate menu. I want to know where they intersect, so I'm going to choose number 5. And then I'm going to follow the prompts. Get your cursor as close as you can to the point of intersection and hit enter 3 times. As long as it doesn't move very much, you can just keep hitting enter until you see the word intersection. And now I know that it'll be about 500,000 people in about 20.7 years, if I round that up. So 20.7 years since 1980. So what is that? That's about 2000, in the year 2000. Okay, if you want to do months, that's up to you. But towards the middle end of that year, okay, you would have 500,000 people. So this is how you would find those things on the calculator. So now we're going to do it using Desmos. So let me switch this out. So in Desmos, we're going to cross out what we had there previously, and we're going to type in this new function. So we're going to type in y equals 300 parentheses 1.025 close parentheses raised to the x. Okay. Now, notice I'm not seeing anything. Okay. I'm not seeing anything because look at what my window was. My window is very small. I know I'm going to have to go up to 300 here. We can, remember, we can click and drag. Okay, we can pinch. Look at that. I can find it just by doing the pinching, the grabbing, the zooming in, okay, whatever you need to do. But I can find what's happening here. Okay. Now, we don't care about what happens in the negative area because we only care from 1980 on. So you might want to go into the wrench here, and you might want to use these features of changing the x-axis. I only want to go from 0 to 30 years out. Okay, and maybe we'll make our steps 5 like we did in the graphing calculator. Okay. Now, just doing that, look at what happened to the graph, right? It looks a lot more like our window in our graphing calculator, okay? So you can start to zero in on what you would be interested in. Same question, I want to know when the population will get to 500,000. It's got blurry for some reason. So in the next spot, we're going to type in y equals 500. Same thing, it's going to draw a line at 500, but I don't have to do anything. I can just touch there, and it's going to tell me when they intersect. So there's no extra places for me to go in Desmos. Okay, it's just going to tell me where they intersect. So really nice interactive features with Desmos. So I hope this all makes sense, okay? Anytime you're doing a word problem or you're generating a table, you can now use technology to verify your answer. I would much prefer that you ask yourself the critical questions first. What is this graph supposed to look like? What domain makes sense? What range makes sense? Before you start using the technology, okay? Because those are the questions that you're going to need to be able to answer. All right, so if you have any questions, please let me know, and I will see you in the next video.